You are listening to EE Times On Air, and this is EE Times Current. I'm Eric Singer. This week's EE Times Current features 3 exclusive interviews recently conducted by Embedded.com's editor-in-chief Nitin Dahad at Embedded World 2024 in Nuremberg. Nitin sat down with Paul Williamson, Senior Vice President for IoT at ARM. He talks with Paul about the new Ethos U85 launch, market challenges for AI deployment, the rapid pace of innovation in AI, and the importance of software and ecosystems. Next, Nitin will discuss machine learning with Daniel Cooley, CTO at Silicon Labs, who will talk about the company's latest chip, the XG26. Noting the industry buzz in recent weeks around AI inferencing, he told us his goal is to put inference on a battery. And our third interview in this episode is with ADI's Fiona Tracy to discuss industrial automation. Fiona highlights the various aspects of 3 key trends in industrial automation today: making manufacturing more sustainable, enabling flexibility by making factories software configurable, and more real-time awareness in factories. Before we jump into these exclusive interviews, a few words about Hardware Pioneers Max.
Prepare to embark on an electrifying journey into the future of electronics at Hardware Pioneers Max 2024 on May 28th and 29th in London. With over 3,000 visitors and more than 100 exhibitors joining worldwide, Hardware Pioneers Max 2024 is where you take your engineering skills to the next level. Head to hardwarepioneers.com and use the code PARTNER50 to get 50% off your ticket.
Hello, this is Nitin Dahad with EE Times, and I'm here at the ARM booth at Embedded World in Nuremberg with Paul Williamson, who's the SVP for IoT at the company. Hello, Paul.
Hi there, great to see you, Nitin.
Well, this is always a great show, and you've always got a big booth, and yes, when you walk in, you've got the big ARM poster as well. What's big for you this year? I think you had a big announcement.
We did, yeah. I mean, this year, everything is about AI at the edge. And at the show this year and today, we've launched our new generation of embedded AI accelerators that are going to be deployed heavily in the microcontroller realm that we'll see in a lot of these embedded devices in the future.
Yeah, just explain a little bit more. It's ECOS, you said.
That's right, yeah. So the new product's called Ethos U85. Okay. And we've had a range of this accelerators that partner well with our microcontrollers for a period of time called Ethos. So typically seen with Cortex-M, and you see that in products today from companies like Himax or Infineon, where they've got their Ethos U55 alongside the Cortex-M55 typically. This generation, the Ethos U85, takes a 4 times in performance improvement. It's 20% more power efficient for the same kind of workloads, and it also supports transformer networks, which is a key new technology in the world of AI.
Yeah, I mean, generative AI, transformer networks. So what kind of applications are you seeing already? I mean, you must have been talking to early customers.
Yeah, we talked to a lot of customers, and the first generation of our Ethos products was used quite heavily in sort of lower frame rate sort of applications, things like face detection or posture detection. With the use of transformers, people are able to have more efficient video-based processing than convolutional networks. So one of the early applications is enhanced video systems. So we're seeing it being deployed in industrial for applications like fault detection or defect detection on production lines. Continued work in smart cameras that are getting ever smarter for the smart home, able to really detect events rather than just say a person or not a person. And also in areas like retail for things like warehouse volume and inventory monitoring and these kinds of applications. So a huge range of applications where people are just using more video-based sensing to detect a whole range of events and be able to customize AI algorithms to work in those environments.
I mean, it's all about AI now. I know everybody I talked to here in the last few conferences I've been at, it's all about AI. What are you seeing in terms of real stuff that you've seen with the AI stuff? I mean, at GTC, for example, everybody was talking about the big chip. But I guess you're seeing quite a range going down to the IoT level.
That's right, yeah. AI is being deployed everywhere, and clearly the big focus has been on things like large language models in the cloud, and absolutely they have a really critical role in the future of AI. But if we're going to be effective with AI, there are some environments where we're going to need to deploy it locally, whether that be for reasons of latency or cloud connectivity limitations or power consumption. And it can, AI is a way of solving, information problems and doing that locally. So we're going to need a range of scale of solutions that allow you to deploy these in a broad range of devices. But the key challenge, I think, for the industry, and one we're working hard on, is making sure that the software ecosystems stay aligned so that developers can target a range of different hardware solutions, but work in those common frameworks like PyTorch or something similar.
And you're good at ecosystems as a company. You've got some other sort of developments around that?
Yeah, I mean, as you said, we're critically sort of well known for our ecosystem development, and we've got a huge number of software developers and different tools partners that are working in this area. So AI developer flow for edge devices is something we're integrating into our own tools like Kyle. We're working with companies like Keekso, part of TDK, who are delivering sort of ML auto tools for generating new algorithms, or Edge Impulse to allow people to bring models down to the edge. But even NVIDIA, who you mentioned, we have a demo here with NXP where we're taking Tau models and deploying those into an IMX device for video applications at the edge as well.
Yeah, I think I wrote something about a paper published by Apple on I think large language models on the edge, or on small language models. Yeah. So that's kind of where we're all heading, I guess.
Absolutely, potentially. We're seeing a lot of interest in what you could do with a large language model approach in an edge device as well. So we have another demo here where we're running, as you may have seen from others, on ARM, just small cores, A510 type cores, running large language models with sort of 7 billion parameters in about 1.5 gig of memory quantized, allows you to do about 10 tokens per second, which is about the rate of human reading. So you can actually do a fairly good large language model locally on a device. Yeah. But as you say, in an edge device, there's these interesting concepts we're seeing where people are looking at smaller training sets where, rather than have a natural language processor that only handles a couple of keywords, you could actually ask a more open question to your device, like, why is my Wi-Fi not working, to your router, and have it give you a much more intelligible response of, I'm not seeing the connection to the Ethernet or whatever it is in real time.
Well, I think I saw from Synaptics yesterday, they've got that whole kit enabling that to go on there. But you've got stuff with Ambic and others.
Yeah, so Synaptics a great partner, and it was incredible to see them launch a pretty broad range of performance points in IoT.
Yeah, the Astra, the SL processor, and the Machina.
So some great ARM platforms there as well, with sort of acceleration for AI. And here at the show we've also seen Ambic launch a really low power embedded platform that's using our Cortex-M Helium instructions to accelerate AI applications as well. Alif have launched an updated connected microcontroller with an Ethos-based accelerator in it, and Infineon with their PSOC Edge continuing to adopt ARM-based Cortex-M alongside Ethos to accelerate these kind of embedded ML algorithms.
And what are the challenges that ARM is seeing in the market at the moment, and also your customers?
So I think the challenge is that moving world of AI frameworks and software, and I think something like transformers a few years ago was not where people were focused. They were looking at convolutional networks, and so a lot of the early acceleration was targeting convolutional networks. Transformers bring this new matrix by matrix and active weights during the execution, which means a shift to the hardware approach to get the highest utilization of the accelerator, and a need for the software tooling to adapt as well. So we've had to invest to make sure those underlying software frameworks remain completely consistent, but allow you to get the highest utilization in the hardware when you use the newer products.
And the other area, I think, it's probably not your area, but the CSA, the chiplets, how's that going?
So chiplets are a really exciting innovation, less applicable in Edge IoT immediately. As you well know, the sort of cost economics that drive the use of chiplets really serve well data center applications, where we are going to see new chiplet initiatives that allow people to bring together and effectively compose systems of compute or acceleration to the specific needs. And the ARM architecture really has enabled people to unlock that potential. And announcements like Google's investment in using ARM in the cloud yesterday show that it's really resonating with people that they want to be able to use customized levels of ARM compute along with their own accelerator to the right tailoring of the workloads, whether that be running YouTube or whatever it is in the cloud. You can really tailor the compute to the optimal solution.
Now, this is probably not the right approach, but can you have IoT chiplets to put stuff in?
It may be something that could happen in the future. I think when I look at it, the cost economics of monolithic still remain so compelling for deeply embedded applications. But there are applications I can see certainly where we're seeing AI edge platforms, and we even see a growth in sort of module and standard board development. So we see a huge amount of innovation happening on things like Raspberry Pi with various carrier add-ons as a way to sort of experiment with what use cases are feasible. But equally, that can carry to quite moderate volumes in real applications. So people increasingly using compute modules as an approach. So it may not be chiplet level, it might be board level and modules, but it's still very much an area of innovation we see that allows you to compose these different performance of systems.
So what excites you most about what you're doing?
I just think watching the innovation we're seeing on edge with AI and how that sort of marries into cloud. So, one of the things for me that's been most interesting about launching this show is we're here. We've got an FPGA demo of the Ethos U85, and we're still probably 12 months from most developers having U85 based silicon in hand. But with our ARM virtual hardware platform, we're able to see people, recompiling the code they've already generated for the current generation U55s, and seeing in the demo here, we're showing a 10x improvement in performance because it brings more of the transformer network onto that device. So just seeing the rate at which we can see software development happening and the pace at which ML is improving the way that people can solve problems in the industry is really exciting.
One of the things you mentioned there was code portability, which is actually quite an important one nowadays because of the time to market.
Yeah, absolutely. So time to market's really key for everyone in that supply chain. The pace of innovation with AI, as I keep saying, is huge. And so being able to reuse code and just hit the new platform and be consistent across different hardware performance points is really key. I think the other thing is then also the silicon vendors themselves. So with the Ethos U85, we also brought out a Corestone, which is our sort of reference implementation. And there we put together the Cortex M85, our highest performance Cortex M, the Ethos U85, and an ISP so that you can do the preconditioning for a camera. And that kind of thing helps, innovators wanting to do new silicon accelerate their time to market as well.
Well, Paul, thank you very much.
Great to speak to you as ever, Nitin. Thanks very much.
Hello, I'm Nitin Dahad with the Times, and I'm here at the Silicon Labs booth at Embedded World in Nuremberg, and with Daniel Cooley. Hello, Daniel.
Hi, thanks for having me.
Well, yeah, this is our annual get-together, and for the embedded industry, but for us as well. What's new here? I think I always ask you this question to start with.
Well, I think the big thing at the show you're seeing everywhere is machine learning.
Yeah.
I mean, we've been talking about it for a long time. You're seeing a lot of products now being launched with it. It's in one of our demos behind me, actually. ML is everywhere, kind of what wireless was 5 or 7 years ago.
And you've launched a new chip as well.
Yeah, our latest chip, the XG26, it's really built for 3 things in mind. One is machine learning, so it's got really, really, really efficient machine learning on it for inference. It's got enough memory for the latest wireless standards, especially Matter, which is about to go big, needs a lot of memory on there. Third thing is a lot of our customers are trying to put their applications onto the chips as well. It's like a one chip in the system instead of an MCU and a wireless chip staying next to each other. So that XG26 really services that need.
And I'm hearing a lot of that actually at the show about the levels of integration, to try and minimize real estate, cost, power, and also power consumption.
There's a ton of reasons. Integration's been the history of the entire semiconductor industry.
Sure. Yeah.
So we're seeing the convergence of wireless and compute and sensing and machine learning and security all together on one chip. Not just for functionality, but it's easier in some ways to build a product. Use one code base to secure, for example, or it's a smaller real estate on the design. So a lot of designs are getting smaller and smaller. It's lower power. There's a bunch of good reasons for doing that.
Now, machine learning, a lot of the attention has gone to the inference, the training and whatever, but how much can you go on the device in terms of inference and activity around that intelligence?
Our goal is to put inference on a battery. That is not an easy thing to do still, even today, and we're working our way, down that path. But how would you do wake word detection on a coin cell battery? That's the kind of thresholds we're trying to push.
And are you seeing a lot of that around the show, or your partners, your customers?
Absolutely. Competitors, others as well trying to do this. It's a market need, not a Silicon Labs, pushing a tool to the market that people don't want. There's basic applications, anomaly detection is one of those, and there's more advanced ones with audio systems or even lightweight video systems that are out there trying to do people counting, maybe not facial recognition on an MCU, but they can count people for sure, those kind of things.
And now, I think you've had quite a lot of announcements over the last few months. Are there any key highlights that you want to talk to our audience about?
Sure. So we announced partnership with Arduino, really trying to make that more scalable, more accessible for IoT. That's something we're always trying to do. Some wireless companies really only want to sell to a couple of customers. We want to sell to everybody. So partnerships with like Arduino are a big deal way to do that. We're pushing state-of-the-art security technology into our chips down at the hardware level. That's something we're going to keep saying year by year by year, but security in the IoT is not just important for protecting data, but for scalability of all that. New wireless standards like the new Matter standard that's coming out, it's like the XG26 is really built for. You'll see more of that coming. And then there's still a proliferation of wireless technologies, like Sidewalk for Amazon is starting to get bigger. And so we're going to be launching more products around that.
Yeah, and I mean, the Matter launch was a big thing, I think, a couple of years ago. I think you've got some real stuff now, haven't you?
Yeah. So it's entering the mainstream. So technology standards, when they're built, don't move fast, right? How many years did it take for Wi-Fi to get fully embedded into computing ecosystems? It took a little while. So Matter's getting big now. And we just recently announced our new generation of products that we call Series 3. So that's well underway for us. It's just the next generation of integration, of security, of wireless technology, of multi-radio capabilities that our current generation's not so good at.
And I know from previous conversations with you, you love technology, and you've got it embedded into your life as well. But what are the things that we can expect over the next year that sort of really are exciting?
Well, I think how we engage with technology is changing. We're moving from screens to other interfaces. That's going to be nice. I personally don't like using a screen for everything. Although I look at that Vision Pro, it's sitting on the face. We'll see how that goes. But the rich interfaces are really coming. A little bit more intelligence into those applications about what you're trying to do and what you're asking. Recently, like my Alexa, when I talk to it knows me now. Alexa, what's the weather? Hi, Daniel, the weather is this, right? Versus my kids. So that was kind of fun. So I think just we're seeing the maturity of IoT and cloud connectivity into embedded come to fruition. And so, the barrier's low, people can add this stuff, it doesn't break the cost or the power budget like it used to, and it's really going everywhere.
And I think security is one thing. There's the CRA in Europe, and then there's the US regulations as well. How is that going to affect your customers?
Well, they've always known security was going to come. Here it is. Fortunately, we have a lot of great tools for them to build their product, to certify their product, to maintain it in the field. So if you're trying to manufacture, develop, maintain, deploy, it's way easier than it was 10 years ago. It was very impossible, I would say, 10 years ago for someone to do that. Hard 5 years ago, not so hard today. It's really, do they want to do it early in their development, or are they trying to turn security on at the end, which they shouldn't do. They should develop it early. But I really welcome this as a consumer. I want my data protected. Our customers are now putting very valuable IP onto those edge node devices that they do not want taken off. Algorithms, machine learning weights. Imagine spending tens of millions of dollars in the cloud on GPUs training an algorithm, and someone buys a $1 MCU and swipes the weights. Yeah. That'd be terrible, right? So you get a lot of benefits once you kind of put the security in, but it's a step function in. Everybody has to pay that.
Well, Daniel, thank you very much.
Thank you, Nitin.
Hello, this is Nitin Dahad with EE Times, and I'm here at the Analog Devices booth at Embedded World in Nuremberg with Fiona Tracy, who's the Managing Director of Industrial Automation for the company. Hello, Fiona.
Hello, great to have you here at the Analog Devices stand.
So there's been lots going on here. I think Europe is a main center for automation, industrial automation, building automation. I've seen some of those things on your booth today. Tell me what's going on in the world of industrial automation.
Yes, absolutely. So it's a very exciting time in the world of industrial automation. It's really a time of transformational change. And we're seeing a number of key trends that maybe I'll just briefly mention. So one of the key trends is this need to make manufacturing more sustainable and to obviously enable more goods to be made locally in Europe. So making products and factories more efficient from an energy perspective, but also making them more productive and driving utilization. So overall efficiency in terms of that operation. Second big trend we see is around flexibility. So making factories basically software configurable automation so that we can change production lines really quickly without having a lot of downtime. And then we can have smaller batch sizes. And the third thing we're seeing is a lot of real-time awareness. So we need to have robots, and we saw great humanoids recently, and even more traditional pick-and-place robots are going through a revolution in terms of real-time awareness. So they're being able to perceive their environment in real time, and that will enable them to perceive what the human is doing and adjust their operation accordingly from a safety perspective. But it also means that they are much more productive, and they can optimally, for example, from an AMR, plan its route around a factory it doesn't have to follow a fixed route. So they're just some high level.
And I heard also from your colleague Rob about the software side, but that software configurability, I think that's a key thing right now, isn't it?
Yes. So what we're seeing is if you want to have flexibility on your factory floor, you need to be able to configure and reconfigure things in real time. And that can be through to like a what we see is an I/O platform that would have been a fixed function in the past. Now is software configurable. It could be an input, an output, analog or digital. And the other thing we're seeing is the connectivity network is really the enabler of flexibility. So can you access all of those nodes in your factory, and can you reconfigure them in real time through your connectivity? And of course, the other big trend we're seeing all over the place is this underlying idea of edge intelligence and deploying more and more edge intelligence locally so you can inform decisions.
So that's the real-time awareness then.
Yes.
It leads into that,
yes,
doesn't it?
Exactly. And it's I think you can go, real-time awareness is very broad in terms of you can relate to it, right? We can understand it. But we can actually have much simpler things as well in terms of edge intelligence, in terms of smart sensors, smart actuators, motion health monitoring. Some of the things we're showing out there is asset health condition monitoring of a motor. So you can signal in real time if there's an issue in terms of it's going outside spec, it's getting hot, it's burning energy. And then you can trigger so it doesn't make a whole batch of defective products before you know it. A whole load of waste, a whole load of defective products. So that's another good example of sensorization and moving intelligence to the edge. I think another example we've seen is, and you've probably seen them on our stand, we have some of the lowest power neural networks in processing, which means you can do AI now at the edge in a battery-powered system.
Okay.
And we're showing some of that out there, again, in terms of vision systems for robotics. And that is very, when we talk about retrofitting factories, that's what becomes really important. Can you do battery-powered or wireless type applications?
So there's a lot there. And what are you seeing, what are the key sort of applications customers you can talk about?
Yeah. So I guess ADI, customers are coming to ADI and they're asking us for help in solving their problems, particularly about deploying intelligence to the edge. And I think one of our core strengths is working in collaboration with customers to really understand their system level problems. And so one of the things we're showcasing on our stand is where we've worked with a partner on sensor fusion for a robot, and where they want to have multiple vision sensing and a really high-speed backplane based off our innovative GMSL high bandwidth connectivity network. Another example, we're working with Lattice on a motion control reference design where they're providing the FPGA and we're providing all of the analog and power capabilities. Power is central to everything, right?
Yes.
Everything needs power,
Yeah.
but it's not for ADI, it's about efficient power delivery, and it's about working with customers to make the right choices so that we can optimize power, not just for a chip, but at a system level and between systems as well in terms of system partitioning.
Wow. Okay. I mean, there's a lot there. So what's next from you?
Yes. So I suppose one of the things in ADI is we have a team of 10,000 engineers globally working on solving some of the most complex customer problems, and they're energized every day by working with customers, by actually getting deep into the domains. And for us and my team, it's all around the industrial automation space. It's all around helping people connect the factories of the future, helping them create adaptive control systems and add edge intelligence and real-time awareness. So things like time-of-flight technology with some innovations we have there. We have a whole host of investments on dynamic motion control, and they're for low power DC motors and, of course, stepper motors. Analog is based on capturing real-world analog signals and interpreting them. And that will drive a data-driven transformation. And at our heart is always precision analog and precision signal conditioning. And that's what we will continue to lead.
It's an apt name, for a world where we're all digital. You need that analog interface.
And I think that is what some people don't understand. The closer you are to the data, and we are at the edge in terms of where we capture that data. And by better understanding that data and the source of that data, we can make better decisions on how to process it and how to get the right signatures to make informed decisions.
Just one last question on the industrial automation front then. Are you seeing a lot of these next levels of automation in any particular areas like automotive or is it sort of across the board?
Yeah, I think there's two big trends, right? One is greenfield, new factories being developed. They will always be state of the art, right? Yeah. They will get the best of everything, and from an efficiency and productivity perspective, they're going to lead the way. So gigafactories are a huge, big investment we see in Europe and other areas. Automotive is always a key investment sector. Biopharma is one where beside us in Limerick, they're building a big new biopharma plant.
Okay.
It's going to be all automated. So that's another area we're seeing investment. I think across the board in terms of sectors. But where the real challenge comes is actually retrofitting brownfield facilities. And they have big constraints, like factory building is constrained, space is a constraint. And of course, they also have infrastructure constraints in terms of what cabling network is used. So capabilities like our long reach 10BASE-T1 and Ethernet enables retrofitting on those existing cables. So that's revolutionary in terms of, can we get IP addressability? So we talked about configurability. You can't configure anything if you can't connect to it. That's what that gives you.
Well, Fiona, thank you very much.
Thank you. Great to talk to you.
Before we sign off, a few words about the upcoming Display Week on May 12th through 17th.
Dive into the future of display technology at SID's Display Week, happening May 12th through 17th in San Jose. Explore cutting-edge innovations, get hands-on with groundbreaking products, and learn from global visionaries. Register at displayweek.org.
That brings another episode of EE Times Current to its end. Thank you for listening. EE Times Current is available through the major podcast platforms, but if you get to us at our website at eetimes.com, you'll find a transcript along with direct links to the other stories we've mentioned and other resources. Thanks for listening.